In this video, I'm going to look at some statistical terms and the underlying ideas. First one is one that you've met before, the idea of a population. So it's not a very difficult idea. It's just a collection of everything. All people in a town, all people in a school, all cars manufactured by a factory, all eggs laid by the chickens on a farm, anything, as long as you just include the lot. So a population is a very basic idea. Raw data, that is information obtained from a population. If we take the chickens on a farm again, we could take all the eggs laid and we could measure the weight of each egg. That would be raw data. If I worked out the mean weight of the eggs, that would not be raw data. So raw data is what you measure. If you process it in any way, you've no longer got raw data. Now we look at the idea of a census and a sample. In a census, every member of the population is observed or measured. Nothing is left out. In a sample, you take a selection of observations from part of the population. Then you use these values to find out or to estimate information about the population as a whole. If we think about a census, if we're examining every member of the population, it should give a completely accurate result. If we are using a census, it will be time-consuming and expensive. If you wanted, for instance, to test the breaking strain of climbing ropes, and you used a census, that would not be very sensible, because how would you test the breaking strain of a climbing rope? You would test it until it broke. And so if you had a census, you would break every single rope. So you cannot use it where the testing process destroys the item. A census on a large population gives an enormous amount of data and is then hard to process. In England, they have a census of the whole population every 10 years. It then takes them several years to process the information. Very expensive, very time-consuming. So because of that, a sample is very often preferable. It is less time-consuming and less expensive than a census. You don't need so many people to respond to your inquiry or whatever investigation you're doing. And you have less data to process than in a census. On the other side, the data may not be as accurate. And the sample might not be large enough to give you helpful information about smaller subgroups of your population. And I've summarized that here. Now, a technical term, a sampling unit. A single member of a population which could be included in a sample. And a sampling frame. This is a list of all the sampling units. You can give a name or a number to list them, from which samples are to be drawn. This is usually the whole population, but not necessarily. And sometimes it's not possible to use the whole population. If you think of the population of Bangkok, can you identify every single person living in Bangkok? That would be very difficult. So your sampling units could not be anybody who lived in Bangkok. You'd have to have some way of listing the people. And once you have made your list, then anybody on that list would be a sampling unit. we have to know what is meant by a population parameter. This is any characteristic of a population. For instance, it could be the mean of the population. It could be the range of the population. It could be the largest value, the variance, the median, the mode, the proportion of red cars made in a factory, etc. Any characteristic of the population is called a population parameter. You have been doing statistics for some time, and I'm now going to tell you what a statistic is. It's a quantity calculated only from the data in the sample. Going back to our chickens, if you take the weight of each egg of the chickens, that is raw data, and a statistic, if you've taken 100 eggs, could be the mean weight of those 100 eggs, the mean of the sample. It could be the range, it could be the median weight, it could be the mode, it could be the variance, but must always be something which you can calculate using only the data you've collected in your sample. You cannot involve any unknown population parameters. For instance, you can't include mu, the mean of the population, or sigma squared, the variance of the population. A statistic is calculated using only the information you've collected from your sample. And the last one that we're going to look at in this video is what is called the sampling distribution of a statistic. A bit of a mouthful. I always try to encourage people to think of the word distribution as table. A frequency distribution is a frequency table. A probability distribution is a probability table. So a sampling distribution of a statistic is a table showing all possible values of the statistic and the probability that each would happen by chance alone. That is a probability table of your statistic. Sometimes you can describe this just by giving the relevant probability density function. Or you can say that it is a binomial distribution and give the number and the proportion. These definitions are, from your point of view, a little bit more important than you might imagine. The examiners are quite keen on setting little questions saying, explain what you mean by a sampling frame. Explain what you mean by a statistic. And of course, they give marks for them. And you might just need those marks. So don't ignore this. Do learn what all these things mean. And then if you need the marks in the exam, you'll find them easy to get.